Good morning, everyone. Um, so I today we are going to continue to use WebEx. I've not been able to yet figure out about the unmute part, but starting Monday, I've inquired that Google Meet should allow us to have this large class size now. So we will switch to Google Meet starting Monday. Okay, so I didn't send the meeting invite for Google Meet because I didn't wanted you guys to get confused today. So once I communicate with you today, we will be changing the platform to Google Meet from WebEx. Okay, so just bear with it today, and from Monday we will be switching to Google Meet, and there you should be able to unmute yourself. So for today, if you have any questions, continue to use the Q&A section. Okay. All right. So let me start with the recording. And before we start with the lecture, if any one of you have any questions, you can put it on the Q&A panel, and then I'll reply to that. Any questions from the previous lecture, or any questions from the content that we have covered so far? Okay. So basically, what we covered in the previous lecture was the shell scripting part, and we looked at what are the various constructs that we can do, we can use as part of the shell scripting. There were still a couple of topics which we still need to cover. One is the redirection part, which we were covering, right, as seen on this slide. And then there will be one more slide on the functions. Okay, so you can also write small functions if you want to in the shell script. So if you want to have multiple functionality implemented in the shell script, you can write various functions either in the same shell script or in the different shell scripts, and you can actually call one shell script from the other also. So there are various options that are available which you can use. So that is what we will go through today, right? So let me just get this thing. Okay. Now, so in the redirection part, what we had covered was a couple of things, right? So one thing we covered was the standard input device redirection. Okay. And we said that you can actually redirect the standard input, which is your keyboard. So for example, we took an example of a cat command where we said that you can take the input from the file instead of taking it from the keyboard. We also did another example where we read the file line by line in the while loop, and we said that you can use the redirection operation, the standard input redirection operation, where you can read the content of the file line by line and in the while loop, and you can display the content or whatever operation you want to perform on the file, right? That you can do. We started looking at the output redirection, right? And we said that we can use the greater than sign to redirect the standard output, right? So we said that we can redirect the standard output by using this greater than sign. And I think I showed you an example where we can say that, let's say we have a file called foo, right? So foo.txt is there. We can then do cat foo.txt greater than output.txt, right? And what this will do is, instead of displaying the content on the screen, right? And this basically content is coming to the standard output device. okay, standard output device, which has a file descriptor of 1, right? So instead of displaying the content in the output device by using this greater than file name, right, greater than symbol with the file name, we are basically saying that instead of displaying the content on the screen on the standard output device, put that content in this particular file. Okay, so that is what we are doing. Now, we also said that if you want to add the content to an existing file, then you can actually use greater, right? 2 times greater than sign. So maybe I will just have another file, let's say file read.sh, and then I will do greater than, 2 times greater than, and then I will do output.txt, right? So what this is supposed to do, so let me actually first do cat output.txt, so you can see what is the content in the output.txt, and we can see that it is exactly the same thing as what we have in the foo.txt. Now I want to add the content to the output.txt in addition to what it has with the content of a different file, which is, let's say, for example, I have another file called file read.sh, and I want to add the content of this file, right? I want to add the content of this file into the same file which already exists, right? So I'm going to say output.txt again, and now if I do cat output.txt, I will see that the original content remains, right? And in addition, the new content is added. And this new content is basically nothing but the content coming from the file read.txt. Okay. Yes, I have taught this in the last lecture. I'm just trying to, repeat that so that sort of like you freshen up your, to the end part of the previous lecture. Okay. So, I'll come to the, because we are continuing the same topic. So I'm going to continue with this one now. Okay. Now we also said that if there is an error, right? If there is an error, and the error is basically, we are saying that nop.txt, this file does not exist, and so when you do cat, you will get error message, right? You will get an error message. Now what will happen is if I do cat nop.txt greater than output.txt. Now here what will happen is that you can see that the error is still displayed on the screen because it is coming to the file descriptor 2, which is an error, right? File standard error file, which is the file descriptor, and the output.txt is not going to have any information, right? So output.txt is not going to have information because nop.txt does not exist. Now, if you want to say that, okay, I want to take the standard output content to this file, okay, and also standard error content to the file, right? So one option is, if you only want to take the standard output content to the file, one option is you can do, let's say foo.txt 1 greater than output.txt. So when we say 1 greater than, what we are saying is that this is the file descriptor of my standard output device. So I'm going to take the file descriptor of standard output device, and the content that is going there for the standard output device, that is what I want to put it in this file. So I'm clearly specifying that the content of which device has to go to this particular file. Okay, so this is one option. So here what will happen is, again, only the content of the foo.txt will go to the output.txt, right? Because the foo.txt's content was supposed to be displayed on my standard output device, which I'm saying has to be redirected to the output.txt, right? And so therefore, now if I look at output.txt again, it will have the same content as foo.txt. Now you can see that it's not appended to the original output.txt. It created a new one because I didn't use greater than. 2 times not greater than is used, right? Only 1 time greater than is used, which means that I'm going to overwrite this file. The old file will be erased, the new file will be created. Now, if you want to capture this error, right, and then put it in this file, what we would be doing? We would be basically saying cat nope.txt and then 2 greater than output.txt. So here, when I say 2, what this 2 indicates? That 2 number indicates standard error file descriptor. So now I am saying that if when you execute this command, if there is an error which is going to go to the standard error device, then I want that error to be captured in my file. Okay, so maybe instead of calling it as output.txt, maybe I will just call it as error.txt. Okay, and now what will happen is, if you look at the error.txt, this error.txt now contains the actual message, the error message, which originally here, as you can see, it was displayed on the screen, right? But instead of displaying it on the screen, now it is captured in the error.txt file. So what I'm trying to say is that you can capture the content of the standard output device using that file descriptor 1 into the file. Similarly, you can capture the standard error content, which is going to also the screen to the to some file. But what if we want to combine both together? Meaning whether the content is going to the standard output device or the content is going to the standard error device. I want to capture both of them in a single file. How do I do that? Right? So there's a special operation that we can do, which is this. Okay. So in this case, what we are basically doing is we are saying that the standard error device is redirected and combined, right? So this and sign says combination combined with standard output device. So basically we are saying that all the content that is going to the standard error also should go to standard output device. And once we are able to do that, then we say capture all the standard output to the output.txt. Okay, so what does it mean? It means that whether the content goes to standard error device or the content goes to standard output device, all of them will be redirected to this particular file. So this way, whether we get an error or whether we get a normal content, right, normal information, both will be captured and it will be outputted into this output.txt file. So you will see that if I run this command, right, so there is no data coming to the screen, and if I look at cat output.txt, this data is going to this output.txt. Okay. Now similarly, if I run this one, right, which basically is going to throw an error actually, right? So this message throws an error because nope.txt does not exist. So in this case, it is actually going to display the content on the standard error. But because I am saying that standard error also has to be captured along with the standard output and has to go to this output.txt, now this output.txt will contain the error, right? That is what I'm expecting. And you can see that happens. So in short, what I'm trying to say is you can actually use this particular option, right? 2 greater than and 1 to combine the the data that is going to both the device, and you can capture them in the file. Okay, any question with this one? What if the command does not give any error when we use the greater than 2 capture? So in that case, what will happen? So your answer to your question is, if it does not generate any error, the output file, the file that is trying to capture the error will be empty. There will not be any data there. But if the data is going to come to the standard output file descriptor, which is 1, then the data will be displayed on the screen. Okay, so if we do this, get foo.txt 2 greater than output.txt. So in this case, I'm saying that only capture the error into the output.txt. But the foo.txt does exist, and it has a content which is supposed to be displayed on the screen by default, right? So now if I run this command, you can see that the data is still coming to the screen, right? And your file, the output.txt, will be empty. There is no data there because there was no error. Okay, so this is what happens. After the command nop.txt greater than output.txt, why it doesn't have any context? Well, because when you do just greater than sign, you are capturing not the error, you are capturing the content of the file. But the nop.txt file does not actually exist, which means it doesn't have any content in it. Right? So if the nop.txt did had a content, then you would not get an error. Instead, that content would have gone to the display like foo.txt does, and that content would have gone to actually output.txt because we are redirecting the standard output. But nop.txt file does not exist, right? So which means that it doesn't have any content, it generates an error, right? So therefore, if the file does not have any content, how would you redirect that content to the output.txt, right? So that is what happens. I hope it answers Hemang your question, right? Okay, so Tarang is asking, could you please explain the last command again? When you say last command, which one? I don't know which last command you mean. Are both output.txt file different? Though the file is same, I'm overwriting the same file again and again. So answer to certain questions, guys, like I said, you guys will have to try out these examples yourself, right? If you don't try out these examples yourself, you may not be able to understand everything, right? So I would request you that if you can try out these examples yourself and also get a better understanding out of it, right? The output.txt when run should display both the error and the error line. So basically what I said is, if you do that 2 greater than and 1, then the output of the file, if the output is there, then the output will go to the output.txt file. If the error is there, then the error will go to the output.txt file. I don't think it will happen that you get an error as well as there is an output, right? So either you get in this particular case, right, in this particular command. Now it may be possible that you are running a very big shell script, and if you are capturing the content of this shell script, the output from the shell script into this file, you can do that also. So for example, I can actually run, let's say, file read. So let me run file read.sh, and then I can say greater than output.txt. I can do this also. So whatever the content that is supposed to be displayed on the standard output device from this shell script, all of that content will go to the output.txt. Okay, so that also I can do. So if I look at now cat, so this is the content that is coming from file read. Okay, that's what I'm saying. Yes, so 1 greater than and just greater than is doing the same thing, correct? Okay, command in which both the standard output and standard error were redirected. Yeah, so basically what happens is that if you reverse it, right? So I think Kavish is asking, if we do 1 greater than and 2, then what we are saying is that if the content is supposed to go to the standard output, then that content has to combine with standard error, and then the standard error will have to be redirected. In that case, you will have to change the command slightly. So in that case, what you will have to do is something like this. So let me go to that previous command which we were using. Yeah. So in this case, what you will have to do is something like this. You will have to do 2 greater than output.txt, and then you say 1 greater than and 2, right? So this we can do. So in short, the first number is the number that is going to combine with the second number. That is how this command works. Okay, so what we are saying is whatever data is going to go to standard output has to go to standard error. And now you are capturing standard error over here. Okay, so this is one way of doing it. The other way I already showed. Right. So, this is the way this redirection thing works. I hope I have answered all your questions. Okay. So now, if I look at output.txt, you will see that the error is there, right? Because I said that the standard output and standard error will be combined, but the standard output information goes to standard error. In this case, there is no output from standard that is going to standard output. So therefore, norm.txt is going to just give me standard error message, which is then captured in the output.txt. Okay, so this is how your standard error and standard output works. So again, my request, my suggestion is that every single example that we are trying out, I cannot test it in the lectures, because otherwise we will be spending whole lecture on just one topic and we will not be able to progress it. My submission, my request to all of you is, I am going to give you a basic understanding of all the commands. My request is please run the code yourself and try out all the combinations that comes to your mind to see exactly how things work. Okay. And if you don't understand something, definitely come back in the next lecture. Okay. All right. So next thing, because see, even though we had covered half of this topic, we took like half an hour almost for this particular topic, right? So that is what I'm saying. Otherwise, we will be hung on the same topic for the whole lecture by trying different examples, right? So my request is, you guys should understand the basics about the topic here in the lecture, and then all the different combinations you want to try it out on your computer, right? Once the lecture is done, so that you understand it in a better way. And like I said, if you don't understand something, bring back to the next lecture. All right, the next thing we have is the functions, right? So you can use functions also with the shell script. So in the function, basically, it's a pretty simple syntax. You have the function name and then the brackets like this. You do the parenthesis. You have the open curly braces and close curly braces. And then you can write all the shell script command that we looked at, right? So you can write the if loops or if conditions, loops, while loop, for loop, all of those things that we have covered, all of that we can do, right? Now in functions, also, if you want to pass the parameter, right? So let's say we want to pass the parameter to the function. Normally in the C code, we pass it in this bracket, right? So in the bracket, we write the parameter names, and that is how we actually pass the function parameters. Here in the shell script, the parameters are passed exactly like what we pass in the command from the command line, from the terminal window. So we don't pass the argument like we normally do in a C program. What we do is, we in the function also, we pass the parameter as if they are command line arguments. Okay, so you can see what we did here. To invoke the function, we are just calling the function name, and then I am basically saying that $. What $* means? $* means that all the command line arguments that we have received from the terminal window in this shell script, when I execute this shell script, all the same arguments I want to pass to the function. So basically, the arguments that came from the command line, from the terminal window to the shell script, the same argument list, the same argument list, because it is an array, right? It is an array, the word array. So all of that, I want to also pass it to the function. That is what I'm doing, right? So I'm basically passing the same command line values to the function. and then function is using that to do different things, right? So it's checking whether I have passed more than one value or not. If I have not passed more than one value, that means I know that there were no parameters passed. If I have passed parameters, then I'm just going to iterate through it, and then I'm just going to display the display the value of each parameter. And then I'm also going to return from the function, right? So there is a return function which I am returning the number of parameters that I have passed to the function. And that is again going to be captured using the $? Sign. Okay, and $? Sign is going to then capture that value in the RET variable, and that variable is. So in short, what happened was this part of the script is sort of like your main function. It's your main script, and this part of your script is basically your function, right? Declaration of the function, and this part is your calling of the function, or you can say main function. So we can run the shell script like this, and basically, if I run the shell script, right? So I can say function .sh space ABCDEF XYZ, let's say, for example, 3 values I'm passing. In that case, I get this information. So I get, ABCD I passed. So first value is ABCD, second value is DEF. And so these values are coming from my function, right? The function part, because you can see that there is a for loop here. So this for loop is actually displaying each of these values here. Okay, so those values are coming from the functions, and the return value, right? This particular one is actually coming from my main script, because I'm displaying this over here. So I call the function by the same parameters which I got from the terminal window, and then when the function returns the value, I'm just displaying that return value right over here. So this is how you can actually implement a function. Now, we can actually call a function from a different shell script, okay? So what I'm going to do is, now in this case, I don't want to use this shell script as my main shell script. So I'm going to actually comment these lines out. Because this is not my main shell script. This shell script, I'm only going to use it as if I'm just defining the functions over here. Okay, so all of my function, let's say, is over here. And then I have other shell scripts which are then calling this shell script, calling these functions in the other shell script. So to do that, what we can do is something like that. Okay, so source is the command which basically takes the code of whatever is written in this shell script and embeds that code over here. Okay, so this is not executing the shell script here, right? So execution of that shell script, if I want to do that, I will have to do ./function.sh, which is what we do normally on this terminal window to run the shell script, right? So this is what I can do if I want to do that, right? And which is fine. I can do the same thing. So let's say, for example, I can actually do, let me comment this line out, and I can do this, and then I can do A, B, C, D, E, F, and so on, right? And if I run this, what will happen? So that shell script is called function call. Nothing happens. Why nothing is displayed? Because I've not actually called a function, right? I'm just running the shell script. And when you look at the shell script, it doesn't have a main code. So therefore, it is not doing anything. Okay. Now, if I had this code enabled, then it would have called the function and done all the things that we did earlier. So instead of running a shell script like this, I'm saying I want to actually include the code of that shell script in my this shell script over here, right? So if you want to do that, you use a command called source. So when you say source, what does it mean? It basically takes the source of this function, of this shell script file, and it embeds or includes that code over here. Okay, now I can then call that function with whatever parameter I want to pass. So this is how also I can call the function in a different shell script. So now if I run the function call, then you can see that now the values are being displayed properly. Okay, and why it is displaying properly is because now it is including that function code which is written over here into this shell script at this place. So it will kind of expand the function.sh and it will include that code over here, and then it will call a particular function that you want. Okay, so this is how the function call works. Any questions on the function? Okay, let me see. So if we have two functions named hello and hello2, then how will we capture the return value of two functions? So basically, you have to call individual functions like this, right? So the return value will be, so it will be like this. If you are talking about this particular code only, then it will be like this. So for example, you do hello1, right? And then you capture it like this, okay? And then you call again a hello2. So if you have two functions, you can call hello2 here, and then call the, and then capture the return value. See, functions has to be called individually, one by one. We cannot, we cannot call. Sorry, where did it go? We cannot call all the function in a single line, right? We have to call one function at a time. So each time when you call a function, it will return a different value, right? And each value can be captured in your variable. What if we have multiple functions in a file and don't want to use the same command line arguments for both? Well, so in that case, you will have to write the separate function call, right? So you will have to write function call 1, function call 2, and so on. So you have to write separate shell script for that, or you can pass different parameters from here. So for example, see, I called this function once and I pass this parameter. I can call the same function again here and I can pass a different parameter. Now you see the same function is called twice with different parameters. So you can do all these kind of things, right? Can we have a function argument like hello something? Yes, you can. What if the source code is present in the subdirectory? Well, you can then put the path. You have to put the complete path. Okay. So here you have to put the path. So let's say slash subdir. See, again, my request is, before you ask the question, think whether you can test it yourself or not, right? These things you can test it yourself. So what I'm trying to say is that before you ask the question, test it yourself. If it doesn't work, then you ask, right? These are very simple things. I mean, you would be able to test these things yourself once the code is available to you. I have already provided you the code. While calling function, can we pass the arguments? That is what we are doing, right? While calling function, pass the argument. That is what we are doing. We are calling the function and we are passing the arguments. Achha, calling function.sh, can we pass the argument? We can do that, but see, basically there are two ways to execute the function.sh, right? So one option is this, right? The second option, as I mentioned, is like this, function.sh, and then you can pass the argument, ABC, PDF, whatever, right? In that case, you have to keep the main code over here enabled. You have to keep the main code here enabled. If you do that, then it will be fine, right? So then you don't need this code. You don't need this code. At the runtime. So the embedding happens at the runtime. Answer to Tarang's question. Embedding happens at the runtime. Can we define a data type for a variable in the shell script? No, there is no data. So shell script does not use data type. it just it's a typeless programming language. Okay, so I can actually say I equal to 1, or I can say I equal to ABC, and it will basically consider that value as whatever you want to consider, right? So basically, most all of these values are taken. I mean, the data type of the values are decided based on the value that you input. So there is no specific data type that you have to use. Any other question? Okay. So that is what the thing about the functions are, right? And that is what I wanted to cover with the functions. Now, this is basically the chapter that covers the shell script. I have given some exercise which I'll be putting as part of the as part of the quiz. So you will basically get to try out these examples yourself as well, right? So basically, again, every time I will request basically the same thing, that we will definitely try to run certain examples in the lectures for better understanding. But all different kinds of scenarios can be there, right? One liner shell script, you can run it various ways, right? So all the various ways we may not be able to test during the lecture. I request all of you to take the shell scripts or any code, in fact, and whatever questions that you have in your mind, try to run it in those different, because that is the best way to learn this course. Okay, that is the reason I'm actually giving you the code. That is the reason I'm giving you the code, so that you can take the code and you can run it yourself and see it yourself how it works. And you have all kind of different scenarios that may be there, and you can try those out yourself. If you don't understand why certain output is coming in certain way, we can definitely discuss that, right? All right. So this is about the shell script lecture. So I'm going to close the shell script presentation, and we will start with the next set of next lecture basically. And this lecture I have kept it for a particular reason. Now, I know that all of you have gone through the C programming course, right? IT112, 113. And you would have studied C programming in your, I believe, first semester or second semester. There is certain area of C program which we require more in this course. And I want to make sure that you are a bit comfortable working in that area, and therefore I have actually kept this chapter so that we can do a little revision of C programming. Okay, so some of I would say that most of the content that you may see in this chapter maybe you've already studied earlier, but I have kept it so that in case if certain concepts are not clear to you, right, we can make sure that we get it clear, because those concepts are required when we do the programming in programming for the system software, right? So therefore, that's why we are going to cover this. So why we first of all use C, right, or C++ for system software, system programming, right? The primary reason being that the operating system code itself, has been written in C, C++. So if you want to use the functionality that is available to us from the operating system, right, what we call system calls, right? So the functionality that is exposed to the general user from the operating system, if you want to use that, the best way to use them is using C or C++ language, right? So that is one of the reasons we are using that. Secondly, memory management through dynamic memory allocation is very easy. I'm assuming that you have studied memory management in the C programming course, where we have created, we have allocated memory using malloc function, right? And then we have created a temporary area where you can store the values. For example, you could store structure data or linked list data, like that, right? So basically, using the dynamic memory allocation, we can also create various type of data structures. Now, I know that you did not had data structure course. Are you studying data structure course now in this semester, or anyone? In second semester. Acha, you studied in second semester. Okay, great, great. So that is great. So if you have studied in second semester, that is very good, because what we will need to do is that we may not have to write a code to create the data structure, but we need to be able to understand that how the data structure works so that we can use them. Because sometimes what happens is that operating system returns the data in a particular data structure. So for example, there could be a linked list in which the data is coming back from the operating system, right? Or maybe we have to use stack or queues for certain operations. Okay, so if you understand what these data structures are, it will be easier. I'm not saying that it is compulsory, but it's better if we know these data structures, right? Then using C, we actually do program the hardware systems, right? So if you want to program the hardware systems, it is generally done using C, and that's why the operating systems are also written in C. You probably have not heard much about the assembly language, but basically when the computers were designed, right, when the computers were designed, even today, for example, if you want to directly go and program your processor, okay, so you have a processor, let's say Intel processor or ARM-based processor in your laptop or desktop or whatever device you have. If you want to directly go and program your processor, right, assembly language code is the only way you can do that. So what is the function of compiler? What is the function of GCC compiler? Basically, GCC compiler takes the C code and converts it into this format, into the assembly code format, so that your processor can understand what you are trying to do. Okay, so again, this is something that we will study when we cover the steps of GCC compiler, right? How the GCC compiler actually takes the C program and converts it into the assembly or machine level code, right? So that is what we will study also, right? So this is another reason we are using C programs, C programming language, right? Okay, so I'll start with the basics, and we will go a little bit in advanced topics as we go through this chapter. So obviously we have some primitive data types in C, right? We use the character data type, which is then indicated by %C type of data. We have a short integer type of data, which requires 2 bytes, right? So short integer data is stored in 2 bytes format. We have a regular integer, which is stored in the 4-byte format, that is represented by %D as a control character. You have a signed and unsigned integer also. So signed and unsigned integer are basically, unsigned integer is where you consider that all the values are positive. Okay. Signed integer is where you consider all the values to be having positive or negative value, right? So if you consider that integer value is an unsigned integer, you use this format, unsigned int, right? If you just write int without unsigned, that means the numbers can be positive or negative. But if you write unsigned, that means the numbers can only be positive, right? You have a long integer, right? You have a floating point values, and then you have double precision floating point values. So these are all the different data types that we have. Float values are represented like this. You can also represent the numbers, right? If you have the numbers like integer numbers or something, you can actually represent in the hexadecimal format. I'm not sure if you're familiar with the numbering systems, but if you're familiar with the numbering systems, you may know what the hexadecimal is, right? We had a course in which we had introduction to assembly code in the third semester. Okay, good. Okay, good. So which assembly did you study? Did you study ARM assembly or did you study Intel based assembly? ARM. Okay, fine. So I think Professor Bhatt must have taught you. Okay, all right, got it. Thank you for the information. Okay, the next thing we do is study obviously the operators. Basic operators we have in C is arithmetic operators, right? Relational operator, logical operators, increment decrement operator. Again, you can use it as a pre or a post increment decrement. You have an assignment operators, you have a ternary operator, and then you have the bitwise operator. So again, bitwise operators you may not have studied that much in detail. But we may use these little bit in our course because we sometimes deal with the binary data, right? So binary data we deal with, so therefore we sometimes use the binary operators also along with the other operators that we have. So I'm not going to cover the operators like line by line because I assume that that is something that you would have covered easily on your C programming course, right? We have constants, macros, and variables that we can use. So this is how we actually define the constants, right? Hash define is the command that we use for that. Similarly, you can define the constants of numeric value. And then this is what the macro is, right? So macro is nothing but your small functions. But without using the regular function declaration, you are just using the hash define. So you are using hash define to create a small function, and that is what we call macros, right? So this is what we call macros. You have the variable of different types. Again, you can define it. You can declare it and initialize it like this, right? Character data. This is the ASCII code I'm using directly over here, right? So 65 is an ASCII code for some character which I'm just storing in my character data. D is the double precision data. F is the single precision floating point data, and then I is my integer value, right? So again, with the integer data, you have multiple options to use unsigned. You can use unsigned, you can use long, or you can use short, right? So you have various types of integer data that you can use. C statements, basic statements that we study obviously is if statements, switch case that we have various loops, construct where we do for loop, which has 3 parts in it, initialization part, the condition part. So until this condition is true, the loop will continue, and then you have the iterative, values right here. You have a while loop, you have a do while loop. You can also use break and continue in between, similar to what we did in the shell script. You can also use go to jump to a particular label if you want to go to a particular label. We have arrays, right? Now arrays can be of a primitive data type, or it can be of a user defined data type, right? So when I say primitive data type or user defined data type, what does it mean? It means that you can actually create an array of, let's say, a primitive data type like character, right? So this is character 20 is basically an array of 20 characters. Now there is a special reserved word called type def, right? So what the type def does, basically, if you want to say that character 20 is the standard data type that I want to use throughout my program, right? You can actually use the type def keyword and then give a name to that type of data. So basically, I'm saying that char20 is the name. I am giving the name to a character data which has a size of 20. So instead of using this particular format every time, I can actually use char20 subsequent to once I do the definition like this. So this is a special way. I mean, basically, this is one of the way you can actually create a user defined data type using the primitive data type also. Okay, so we are using character data type, which is a primitive data type, and we are defining a special user defined data type using that primitive data type using the type def keyword. So now you can see that I can actually use char 20, which will then be used as a data type for some of the other variables. Okay, so in this case, what happened was actually I declared two-dimensional array, right? The first dimension is this 20, and then second dimension is this 10. So instead of declaring the array like C20, 10, right? Instead of declaring the array like this, I actually, and I can say char, right? C2010, right? So instead of declaring array like this, I actually can also declare it like this. We have a special user-defined data type, as you all know, in C, which is what we call structures. So by default, you can only store one value in or one type of value in a particular variable once you declare it. Right. So for example, even in this case, you can only store character type of data. You cannot store any other type of data. But once you have defined the structure, you can actually combine multiple data types within them. Right. So for example, if you want to create a data type called user, now user can have, user ID, username, address, phone number, and so on. You can use a different data type within that structure. We have a structure called student, let's say. A student has student ID, name, and so on, CPI, marks, grades, all that, right? So you can actually create this structure in a particular format so that you can store different type of data, and then using that structure, you can actually create an array or any other kind of data structures that you want, right? So this is this is how you would be able to use the arrays. Different ways to initialize the arrays. You can either hard code the initialization like this using the parentheses like this. So you can say that 10 different values you want to store in a array. You can store it like this. Character data, you can store it like this. If there are multidimensional arrays, you can also store it like this. So these are all the hard-coded way of storing the data, right? Or if it is a structure, again, you can store it like this, right? Or the other way is you can use loops. So if you want to accept the data from a user, you can use loops, right? So either using the loops, you can accept the data from the user and you can store the data in a particular index. Again, the indexing in C starts with the value 0, right? So we start from the index 0 and go all the way up to the size -1, right? Size -1. That is what the indexing is going to be used for, right? So this is how you will be able to accept the data from the user, or if you already have the hard-coded value to be stored in the array, then you will be able to use it like this. We know that whenever we declare a character array, it can be used in two ways. One is a simple character array, the other way is a string, right? So simple character array is basically this, right? So you are just storing one particular character at a particular index, and that is how we are storing this, right? If you want to use this array as a string, then we know that there is a special character called a null character, right? Which is represented by an ASCII code \0, right? So \0 is the character which has an ASCII code of 00, by the way, right? So ASCII code of 0 is the special character called a null character, and that has to come at the end of every string. So therefore, whenever you use a string, right, the character array for this string must accommodate one extra character, which is a null character. Otherwise, so in this case, for example, we are storing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters, right? Here you need exactly 12 characters of size in the array. But if you want to use the same value as a string, right, you need 13. You need the space for 13 characters because the last character will always be the null character. and that null character has to be stored in the string. What is the difference between the character array and the string? Is in the character array, if you want to act upon a complete string, we cannot do that, right? Because there is no null character. So C program does not know where my character array ends, right? It doesn't know where my character array ends. So I have to act upon individual index characters. But for the string, there are special string functions that are given to us, right? Again, this is the way we can read the data in the character array. And you can see that this is the way we can actually read the data in the string, right? So you can directly use just one function, scanf, using a %s. So %s indicates for the string, which assumes that there will be a null character at the end, okay, or getS, right? Whereas in this case, we have to use %c, and this will read one character at a time. And we have to read one character at a time, either using scanf or getChar, right? More string functions are this, right? So you have a string length, which returns the length of the string, excluding the null character, right? So it does not count the null character in the length. String compare, where you compare the two strings, ASCII code by ASCII code, right? So if the string S1 is greater than S2, when you compare the ASCII code values, then it will return 1 or a positive number. It depends on the implementation of compiler or actually the operating system, sorry, the running environment. If the S1 is less than S2, then you get the negative value or -1. And if both strings are equal, ASCII by ASCII comparison, then it returns 0 value, right? You can use string copy, string concatenation, right? Or finding the smaller string from in the larger string, str. So various string functions are there. There is also string upper, string lower. All of those functions are there. I'll just put few of them here, just so that you know that which one works for the string and which one doesn't work for character. So each of these functions will not work in the simple character array because there is no null at the end. If there is a null at the end, only then these functions will work, right? Okay, in the character array, can't we use space between two words? Yes, we can, and that is what we have here. So this one is a space, this one is a space, right? So we can use space, but space is also an ASCII code. Space is also an ASCII code, and there is some special, there is a ASCII code value assigned to that space character, right? So it is not treated as the terminating, it is not treated as a terminating character. The terminating character for string is only this null value, which has the ASCII code of 0. Okay. Now the memory allocation, that is done for variable, right? When you declare the variables, how is the memory allocation is done? So basically, the way it is done is it looks at the order in which the variables are declared, and it looks at the size of the variable, right? So when you look at the int, for example, so you have an int count. Count is the variable name, int is the data type. Now we know that int data type takes 4 bytes, right? 4 bytes. And then you have unsigned character C, right? So you can also use unsigned with the character data type. So you have an unsigned character C. These are the two variables, let's say, I have declared in that particular order. So what happens is that, let's say, from the index 24 in the memory, in my RAM, right, it has started allocating the space for the int variable. Okay, so what will happen? Int variable for the count, right? So what will happen is it starts with the with the first byte here, and then it takes 4 bytes, right? So 1, 2, 3, 4. So these 4 bytes are basically used by the count variable, right? And then followed by that, we have a declaration for the unsigned character C, and which basically takes only 1 byte. So that 1 byte will be allocated over here. So this is how the memory allocation will happen. So for example, in this case, if you look at the pointer variables are all of the same size. Why? Because pointer is nothing but an address, right? I think you've studied pointers in your C programming course and possibly also in your computer organization course, where you say that you use a pointer where the pointer represents the address, memory address. So memory address, the size of the memory address never changes for a given computer, right? So if it is a 32-bit operating system, we know that every single address is going to be 32-bit. If it is a 64-bit operating system, then we know that every single address in that operating system will be 64-bit, right? So each of these pointers that we have, right? And how do we know each of these are pointers? Because we are using the star character. So star character basically is representation of the pointer to a particular data type variable, right? So each of these pointers are of the same size, If it is 32-bit OS, it is a 32-bit value. If it is a 64-bit OS, then it is a 64-bit value. Okay, in character, trying to use space in between words. Yeah, Jill, so you can actually store the value like this, but this is not a character array, because as soon as you do this, after C, there will be a last character that will be included in the array, and that will be the null character. So you can do this, but that means you are actually defining a string, not a character array. Okay, now I want to basically get some idea about understanding as to how this thing works, right? So I basically kept these couple of slides. I have 2-3 slides like this, which basically will understand the testing, or will basically test the understanding of the pointers. Okay. So I'm basically going to ask you these couple of questions, and then please just answer them in the chats, right? For now. So we have, let's say, these two variables declared, I and j, and then let's say we have these 3 pointers, right? Now I have initialized these pointers like this, right? So I have p equal to and I, which means that I'm actually pointing, p pointer is pointing to the address of the variable I. P1 pointer is pointing to the address of variable I. P2 pointer is pointing to the address of the variable j. Okay. Now, if I do this, if I declare a new pointer called double star d equal to trying to point to that d pointer to the address of I variable, can I do this or not? Right? So can I do this or not? Is this allowed or not? That is what I want to know. So some says no, some says yes. Okay. All right. So the answer to the question is it will work. See, basically, it is expecting you to point to the double type of data, right? And your address is an integer type of data. So basically what happens is it will still take the address of I and put it here. But when you try to read the data from the D pointer, so assignment will not give you any error, because the assignment, well, it will give you a warning. Okay, it will give you a warning. It will basically say that you are assigning a different type of data address to the different type. But the problem will be is that when you try to access the data using a D pointer, it is expecting that the data is 8-byte data and in the floating point format, right? So basically, it will not allow you to access the data, right? Basically, it will give you a junk data. Okay. Krupal, you are right. Some compilers do check for the data type, and some compilers no. So again, it is an implementation based thing. So some compiler will directly compare the data type of I variable with the D pointer, and it will give you an error. In some compiler, the assignment will work, but when you try to access the data, it will not work, right? So basically what happens is it depends on the implementation of the compiler is what I'm trying to say. But so in our case, as a user, we have to be careful as to whether you want to really do this because it will not work for us. And I is the address, so isn't it 8 bytes? Yes, so that's what I'm saying. See, basically the address of I is the same size as what we need in my D variable, because D variable is a pointer, right? D variable is a pointer. So therefore, what will happen is that the size that I want to store in my D variable is the same. Okay, is the same. So some operating system, some environment will allow you to actually assign the values because the size is not a problem here. But when I try to access the data using a D pointer, so basically when I say star D equal to 10, for example, when I try to do this, right, or when I try to print the data using the star D, now here star is not declaration of the pointer, I'm trying to access the data from the pointer. When I try to do this, I will get the incorrect value, is what I'm trying to say. So some compiler will allow you to assign the values like this, assign the address like this. Some compiler will not allow you, directly give you an error. But even if the compiler allows you to assign the value like this, your running environment, your operating system will not work properly because you are trying to access the double type of data, which is 8 byte, whereas the I variable only should contain 4 byte of data. Okay. What happens here? Now this will work fine. Why? Because I is a smaller value. You are actually taking the value and storing in the D1 variable. So for example, here is my, let's say 4 byte value, which I'm storing in my 8 byte in the float, right? In the floating point format. What C program, what C, runtime will do, it will automatically convert this integer value into the floating point value and store it in D1, which is basically called implicit casting, right? Implicit casting. So implicit casting means that when you use the lower size, lower type of data for the higher type of data type here, then that implicit casting will be done. So integer data can be stored into double. Character data can be stored into integer. Okay, but the double data cannot be stored into integer. Integer data cannot be stored into character because a character is a single byte, integer is 4 byte, double is 8 byte. So double data cannot be stored in I, right, which is an integer data type. So D1 data cannot be stored in I, and character data cannot be stored in, I data cannot be stored in character data type. So this will work, this will not be a problem. Okay, there will be an implicit data type conversion that will be done. Okay, so that is what this is representing. Okay, so what will happen is this basically will not work because it will be a problem. Now you could actually do explicit typecasting like this if you really want to. In that case, what will happen is this will work, but it will give you a warning. It will basically say that your data is larger if your data is very large, right? If your double data is very large, you cannot actually accommodate that data in my integer data type, right? So that is what will happen here, right? So you can do explicit typecasting like this to convert the double data type into the integer data type. Now, if the size of the data, actual value, if the actual value is very small, you can convert it into integer and store it in I variable. But if the actual value is very large, you won't be able to store it. In that case, you will get the warning. Okay. So go to the next. When you do the comparison here, what is the comparison? What will be the answer here? Answer is true or false for this condition. What do you guys say? Whether the answer is true or false? So here we are looking at size of P. What is P? P is a pointer variable. What is the size of D? D, what is D? D is also a pointer variable. So basically, if my operating system is 32-bit, the size of P and size of D will be 32-bit. If my operating system is 64-bit, then size of P and size of D will be 64-bit. So therefore, the size for both the variables will be the same because both are pointer variables. Both are pointer variables, so therefore the size will be exactly the same. When I look at this second part here, the size will be different because when I say star P, what does this star P means? Means wherever the P pointer is pointing, give me the data of that pointer. That is what I'm saying. I'm accessing the data using the star P here. Similarly, I'm accessing the data when I'm using star D here. And when I say star P, the data that I'm getting back is an integer data type because I'm pointing to I variable. Right? My pointer is an integer data type pointer. So therefore, star P is going to return me integer data type. And the size of integer data type is 4 bytes. Right? But the size of double data type is 8 bytes. So therefore, when I compare the size of P, star P and size of star D, I'm comparing the size of 4 with the size of 8, which is not equal. So therefore, here I'm going to get the answer as false. Okay, here I'm going to get the answer as true. Okay, here what will be the answer? P1 equal to P2. So what is P1? P1 is pointing to I. P2 is pointing to J. Now I'm not doing star here. What does it mean? I'm comparing the address values directly. I'm comparing the address values directly, right? So basically, P1 equal to P2 will be false. Why false? Because P1 is storing the address of I variable. That number will be different. P2 is storing the address of J variable. So therefore, that address will be different. So P1 has a different value and P2 has a different value for the addresses because I has a different address, J has a different address. Those are two different variables. So therefore, this will give me the answer as false. Okay. This will be the answer as true. Why true? Because when I say star P1, that means P1 is pointing to my I variable, but when I say star, that means access the value from there, which is 8. So star P1 will give me 8 value. Star P2 will give me also 8 value. Why? Because P2 is pointing to J and J variable has the value of 8. So therefore, star P1 will give me 8 value, star P2 will also give me 8 value. And therefore, when I do this comparison, they will be equal. Okay. So what I'm saying is P1 equal to P2 is false, star P1 equal to star P2 is true. P equal to P1 is also true. Why? Because P is an address pointing to I variable. So the address of I is stored in a P variable. Similarly, P1 is a pointer pointing to I variable address, right? Pointing to I. So that means again the address of I variable is stored in P1. So the address stored in P and address stored in P1 both are same value because both are pointing to I variable. So therefore, this is going to give me true value. Okay. So this is how the, so this one is false, this one is true, this one is true. Okay. And let's look at this last example. If we have k equal to 8 int star p3, and then I do p3 and k, and then star p3 equal to 12, what happens to the value of k? The value of k will change to 12 from 8, because p3 is a pointer pointing to the address of k, right? So p3 stores the address of k by this assignment here. And so now when I say star p3, what does it mean? It means that wherever this address is pointing to, go to that location and change the value to 12, which is the same location where the value of k is stored. And therefore, the value of k will change to 12 from 8. So again, this is the information, this is the idea you should have, right? These are basically for the primitive pointers. I also have some more examples with, with arrays or some complex pointer thing, which we'll take a look in the next lecture. But basically, I want you to make sure that you have a good understanding on this one, because many of the, or not many, but some of the assignments we will have to use pointer arithmetic and traversing through the linked list and things like that. So if you have a good understanding of this area, it will be helpful, right? So you will be able to understand the code better when we look at it. Any more questions? Okay, so we have some more questions. Let me take a look at it. When I create shell script in gedit, by default only the read permission is granted. I have to change the permission before it. Okay, I think what might be happening, Krupal, is that you may be creating a shell script in the directory, and the basically what happens is whenever you create a shell script, it is taking the permission that you have in the directory where you are creating the shell script. So if the directory that under which you are creating the shell script, if that directory does not have the other permissions given, then your shell script will inherit whatever permission that the directory has. So change the permission for the directory and then try it out. I don't understand your question, Jill. What about quiz question? What are you asking? I don't understand. Yes, I will be sharing this lecture slide immediately after the lecture is done. Okay. I was not sure how far we will be able to go, so I've not shared it, but I'll do that immediately after this lecture. Okay, any other question? All right, and please make a note that I'll actually update the current Google Calendar invite and change the meeting link to Google Meet instead of WebEx. Okay, so from Monday we will use Google Meet instead of WebEx. Okay, thanks everyone for joining.